With so many homeowners now installing warm water underfloor heating in everything from new build to renovations, barn conversions to extensions, and even conservatories, new heat is now quite literally changing the way in which the nation heats its homes. But what exactly is warm water underfloor heating? How does it work? How's it installed? And what are the benefits in having it in your home? Today I'm visiting a home which already has a new heat system up and running, but we'll also be looking at a system being installed to find some answers to these important questions. A new heat warm water underfloor heating system works by pumping temperature controlled warm water from a normal central heating boiler through jointless plastic tubing embedded in the floor. A thermostat located in each individual zone calls for heat, which in turn opens an actuator valve on the Optiflow manifold, switching on the pump and the boiler. Warm water flowing through the tube raises the floor temperature to a few degrees above the room temperature. Heat then radiates from the floor until the temperature set on the room thermostat is reached. The thermostat then switches that zone off, and unless other zones are calling for heat, the whole system switches off. Because the whole floor is being used as a heat emitter, you only need a water temperature of around 55 degrees centigrade to get the same heat output as you would from standard panel radiators. And once the tube is under the floor, you can forget about it, because it's covered by a 25-year guarantee. The system can be used throughout the property with a wide range of heat sources, including almost any type of combi or standard boiler, range cookers, geothermal heat pumps and solar power. In the project we'll be looking at, the system is being installed on both floors. It's connected to a gas condensing boiler and has a mains pressure hot water cylinder. Heating from the floor has some obvious and some maybe not so obvious benefits. One of the obvious benefits is all the extra space gained for you and your furniture with no radiators taking up valuable room on the walls. You can still have towel warmers in the bathrooms. Perhaps a less obvious advantage of underfloor heating until you experience it is that lovely feeling of having warm feet combined with a cool head, which is the ideal human comfort conditions. Now, new heat provides that total warmth across the whole area, thereby all but eliminating any cold drafts and cold spots. And with the heat being more evenly distributed than with a radiator system, the energy input is less, so the running costs are lower. But now let's look at the new heat system being installed to find out how easy it really is. Before you get to the installation stage, New Heat will have carefully designed the heating system to ensure that your home is split into individually controllable zones. Each zone will have the correct density of fast flow heating tube to meet the heat requirements without overheating the floor. Individual control for all the principal rooms ensures the correct comfort level can be set to suit you. Getting the correct comfort level with optimum control is just one aspect of a detailed and crucial design process, because once it's installed, the system design can't be changed. The result is a design unique to the property. As long as the installer follows the plan, putting in the right number of lengths of fast flow tubing at the correct spacing, things can't go wrong. Now let's follow the installation. At the very heart of the underfloor heating system is the Optiflow manifold. Generally, there is one manifold per floor located in an appropriate cupboard, in this instance at the back of the airing cupboard. From here, warm water is drawn from the boiler or heat source and mixed to the correct temperature before being sent along pipes to individual heating zones. The Optiflow manifold is fitted in the early stages of the installation process, as it's needed to complete the pressure testing. How you install the heating tube depends on the floor construction in each zone. There will probably be more than one. Essentially, they break down into three types: screed, suspended timber and floating floors. The first type of installation we're going to look at is the screeded floor. This is the most popular ground floor construction in new buildings. Screed gives very good heat transfer and works extremely well with underfloor heating. The first thing to do is place the edge insulation supplied by New Heat around the edges of the room. This prevents heat migrating through the walls. Next, standard floor insulation is laid directly over the concrete slab. This is best sourced locally, as your architect or builder will have specified the correct thickness needed for your building to conform with the current building regulations. A polythene protection layer is placed on top to protect the insulation. This can be bought at most good builders merchants and needs to be 125 micrometers thick. Again, this is a building regulation requirement. Clip track is joined into lengths and anchored into the insulation. This is placed at regular intervals across the floor and will hold the tubing securely. The tubing can then be laid out over the entire floor, following the plan supplied by New Heat. The objective of the installation is to ensure that there is a correct amount of tube at the correct spacing. The actual pattern for laying the tubes is flexible, so it could be like this or this. The system has been designed to avoid inaccessible joints under the floor. Any joints are made at the distributor positions, usually in the room that they serve. Each zone then connects back to the corresponding flow and return port on the Optiflow manifold. There are other systems available for different types of screeded floor. Here you can see how the tubing is installed into a screed with timber battens that have been fixed to the concrete subfloor. As self-leveling screeds are becoming increasingly popular, New Heat also supplies a special panel to hold fast flow in place instead of clip track. Once the remaining ground floor areas are completed, the system is filled, flushed and pressure tested from the Optiflow manifold before a standard sand and cement screed is laid. Once the screed is dried, the flooring can be laid. As you can see, tiles, wood and carpet are all suitable for use with underfloor heating. The next floor we'll see being installed is the suspended timber floor, normally found, as here, in the first floor. The floor heating tube can be installed from above the joists before the floor decking has been laid, or from below afterwards. Here it is preferable to install after the deck has been laid. This avoids any delay to the carpenters and potential damage to the floor heating when the deck is screwed in place. Whatever the method, the joist will be in position before you start. Make some provision for getting the tube from one joist bay to the next before laying the decking. This could be by fixing the battens on top of each joist with a gap at either end for the tubing, by notching each joist at the end, or by drilling. Remember, both notching and drilling are covered by building regulations and must be done within the guidelines. Details of this are given in the New Heat installation manual. The fast track clip which holds fast flow tube in place can be fixed in three ways. By screwing up into the deck from below, by hanging from the joists before the deck is laid, or by screwing or stapling to the side of the joists before or after the deck is laid. It's designed to be used with traditional timber joists, steel brace joist systems and TJI or I-beams. In this instance, they've been simply laid across the top of the joists before the decking was installed. Once the fast track is in place, the fast flow tubing simply gets pulled through the notches in the joists and secured into the clips. The next stage of the process is to connect the fast flow tubing to the zone distributors. This reliable jointing system means that multiple rolls of tube can be used within the joisted floor, with only one flow and return pipe back to the Optiflow manifold. Connections from the distributor to the Optiflow manifold are made in the Alupex tubing supplied, and the system is then pressure tested. Finally, the foil-backed insulation is pushed into place between the joists before the plasterboard ceiling is fitted. In this room, a floating floor is being installed. As panels can also be fitted between joists, this floor system is useful where there is a restriction on floor height, such as in a renovation or where there is no time in the build schedule to allow for floor screeds to dry. The tube is placed in the floor in metal heat diffuser plates which are backed onto high-density polystyrene. The panels are placed on top of the floor insulation and the underfloor heating tube is simply pushed into place. The panels are supplied with pre-built 90 and 180 degree turns and pre-scored snap joints, both designed to make installation as simple as possible. The floating floor method can be applied equally well to timber decks and solid floors with or without battens. Again, as long as the correct amount of tubing and tube spacing is used, the actual tubing layout is completely flexible. After all the tubing has been laid and the system has been filled, flushed and pressure tested, chipboard decking is placed on top, giving a surface to lay your final floor finish. The total height build-up is very low and can be as little as 15 mm on top of a deck, or nothing at all if it's fitted between the joists. When the main elements of the floor heating system have been installed, the boiler is connected to the Optiflow manifolds and it's then time to make the electrical connections. These make the system an integrated whole. A word of warning here, electrical work should only be completed by a qualified electrician. Nu-Heat provides an Optiflow electrical junction box which makes wiring the room thermostats, zone actuator valves and manifold pump quite simple. A main system wiring box then integrates the Optiflow wiring box with the boiler pump, radiator circuit if there is one, and cylinder. The comprehensive installation manuals provided by Nu-Heat contain detailed electrical diagrams and each of the wiring centres is clearly labelled. And that's it, the installation is now complete. So, no radiators, giving you greater flexibility in interior design, ease of installation regardless of floor type, economy and outstanding service. It's easy to see why so many people choose Nu-Heat for their home. And as this project shows, Nu-Heat systems are designed to give individual temperature control for any room, whether you choose carpet, wood or tiles. To take the next step, send through a copy of your plans for a free no-obligation quotation to Nu-Heat or call 0800 731 1976. Looking below the surface, it truly is heating that takes some beating.